Alright, so number 60, you've got another fraction here, and you're worrying about dividing by 0, so you set the denominator equal to 0 and solve. When you get 4, that's the number you throw out. Everything but 4. By the way, this domain says the set of all x such that x is not equal to 4. That's how you read that. Alright, on this one you set the denominator equal to 0 and you get two answers, 1 and minus 1. And so x is not equal to 1 or minus 1. You can put a little plus minus there to shorten your answer. But it means the same thing. It means x is not equal to 1, x is not equal to minus 1. 63. Here's our first even root. Even roots, we've got to force to be greater than or equal to 0. So we get this guy here. Then we subtract 2. Divide by negative 1 or multiply by negative 1. Notice the greater than becomes less than. We just multiplied by a negative 1. So now our answer is less than 2 and equal to 2. So minus infinity to 2. Notice with this one, when we get our answer, we throw it out. On this one, when we get our answer, we keep it. That's the difference between even roots and fractions. Notice this is an odd root. There's no problem with odd roots, so the domain is everything. This one's an even root, so you force it to be greater than or equal to 0. And when you solve it for x, you get x is less than or equal to 7/3. Notice I had to switch the inequality because I multiplied or divided by a negative 3. Okay, so, or I divided by negative 3. So we're looking at less than 7/3 and equal to 7/3. So minus infinity to 7/3 bracket. Now this one's got an even root and a fraction. Let's worry about the fraction first, 3 minus x. Set that equal to 0 and solve, so we got to throw out the 3. Now up here we got to set 2 plus x greater than or equal to 0. So we get x is greater than negative 2, and we're going to keep that. So we're going to say negative 2 or bigger, but not 3. So negative 2 to infinity, but we throw out the 3 by using a parentheses there with a union. So the interval from minus 2 to 3, and then from 3 to infinity. So notice we're not including 3 there. 72, you force what's underneath there to be greater than or equal to 0, and now this becomes one of those inequalities, quadratic inequalities, and we set the factors equal to 0, divide up our number line, check them, and we pick the proper region. And so we're looking at minus infinity to minus 2 and 4 to infinity. And so there's your 2.1, which says if you plug in a number into the function, you should write it as f of blank first. Domain, we worry about fractions and even roots. And for fractions, we set the denominator equal to 0 and solve. And we throw out whatever answer we get. With even roots, we set what's under the expression greater than or equal to 0 and solve. And whatever answer we get, we keep it. With the piecewise functions, we look at the input. That will determine what line we're going to use. Choosing the proper line, we plug in the input value and get our answer. And finally, the last one, the difference quotient. We find f of blank, and then from there we find f of a, and we find f of a plus h, and we plug them into here and here, distributing our negative sign when we drop the brackets, and then finally divide by h. And we want to do that very carefully.